And so far, we've only seen this scenario. We've had one solution. That's the point of intersection, right? Wherever that intersects, that was our point of intersection. And we got some x comma y that we got as a solution. So now this is going to come into play, and you have to be able to figure out, you know, what's going on here. So if we graph it, it's pretty obvious. If we graph it and it has the same slope, and you know, it's pretty obvious it's parallel, which means there's no solution because they never intersect, right? They never intersect. Infinite number of solutions. This is when, like I know it says lines coincide. That means they're exact same line, right? So again, the reason why it's infinite is because a line is so many points so close together that it's actually forming this. So that's why we have an infinite number of solutions that is happening when this happens. So here's the problem now. You're not going to graph these to figure this out. How are we going to actually predict how many solutions a system has without graphing? Yeah, so check the slopes. So one solution, what would happen with our slopes? They're different slopes. Okay. What about no solution? What would we know about the slopes? Yeah, they're the same slopes. What about infinite number? They would actually have the same slope, but then what's the... Yeah, so they're going to have the same slope and same y-intercept. So if you were to solve for y, you get the same exact equation. If you were to solve for y for these, you would, it's noticeably different, the different slopes, but the same slope. This would have different y's, though. Okay, so let's look at the first example here. I can't tell anything by the way it's written, right? Do you see that? So what should I do? Yeah, so if I put this into slope-intercept, I get y equals negative 2x plus 8. And if I put this into slope-intercept, I may have to do this in 2 steps. So I'm going to move the 4x over. So I get 2y equals negative 4x plus 16. And then I divide by 2. So what does that become then? Y equals negative 2x plus 8. So how many solutions would there be? Infinite. Does everybody see they're the exact same line? So infinite number of solutions. Hold on. Okay. So if you have it in slope-intercept form to find this, but I actually want to know what the solution is, what happens if it just said solve the solutions? How would I solve this? Well, you could choose whatever method you want, right? So if I were to actually solve this, what do you think this would look like algebraically? So let's solve this. What would be the best way to solve this? Times it by 2? The top by negative 2, say? So negative 4x minus 2y equals negative 16, and then I get 4x plus 2y equals 16. What happens when I add them up? Everything cancels. I get 0 equals 0. So if that ever happens to you, you need to make the connection that that means there's an infinite number of solutions because there's exact same. Okay, so let's try the next one. Okay, so how should we figure out how many solutions this is? Slope-intercept? Okay, so this one's already close to be doing it, so I'm going to move the 3x over. What do I get? Plus 9. And then this one I'll have to do it in 2 steps. So I'm going to move the 6x over. So I get 2y equals negative 6x plus 12. Then I need to divide by 2. So I get y equals negative 3x plus 6. So how many solutions do I have? I have no solution because same slope. No solution because they have the same slope, meaning they're parallel, right? Actually, you don't need a line underneath it for parallel. It just means it's parallel like that. Okay, so let's look what it looks like algebraically, right? Okay, so how would I solve this one? Times by negative to the top. So I get negative 6x minus 2y equals negative 18. Whoops, I don't need a line there. And then I have 6x plus 2y equals 12. Now what happens when I add them up? Well, the left side all cancels and I get 0. But what happens to the right side? Negative 6. And can 0 ever equal negative 6? No. So when you get something like that, that's the indicator that it's no solution there. So if you get something wonky like 5 equals 0 or 10 equals 3, like something that can never happen, then you know that's a no solution. Okay, let's try the next one then. So let's get it into slope-intercept form. So what do we get here? Y equals, yeah, negative x plus 8. And then this one, y equals positive 5x plus 1. So what happens here? How many solutions would I get? One solution. 1 point of intersection, right? So one solution. Okay, so let's solve this. So how could we solve this one? It's actually nicely written, hey? We could eliminate the y's by doing what here? Yeah, so if I put negative to all those, do you see the y's will cancel? And then I get negative 6x equals negative 7. Yes? So what does x equal? 7 over 6. Have you got a few of these in your homework where you have fractions that you have to solve? Because I know some of you are having trouble with the fractions, but I wanted to find one. So now we're going to take that and sub it in. So 7 over 6 plus y equals 8. So I'm going to subtract 7 over 6 to both sides. Yes? So I get y equals 8 subtract 7 over 6. So how do I do that? Okay, put 8 over 1. Multiply it by 6 over 6, right? So that becomes what? 48 over 6. Yes? So 8 over 1, I multiplied it by 6 over 6, so I get 48 over 6. Now I'm going to go 48 subtract 7, and I get 41 over 6. So that means my point of intersection is 7 over 6, 41 over 6. Okay? Are you good? Okay, make sure you practice some of the fraction ones, right? I'm just going to move this up. Okay, so the graphs of 2 equations in 3 different linear systems are shown. System A, System B, System C. Which linear system do the lines intersect at exactly 1 point? C. How many solutions does it have? 1. 1 point of intersection, right? In which linear system are the lines parallel? B. How many solutions does this have? None. Or you can write 0. In which linear system do the lines coincide? Well, there's only one left. A. And how many solutions does it have? Infinite. Or you can say infinitely many. It's up to you. Okay, so now we're going to solve these. You should be really good. So I'm going to give you a second to try to solve this, and then we'll discuss what that represents. Because now that you know what it all looks like. Okay, do you want me to use substitution? Okay, I'm going to use substitution. I know most of you use elimination. Okay, so I'm going to go x equals 2y plus 3. Did you get that? Yeah. So now I'm going to take that and sub it into here. So that means it's negative 2 times 2y plus 3 plus 4y equals 1. So then I multiply that in. I get negative 4y minus 6 plus 4y equals 1. The 4y's cancel, and I get something goofy. And what does the something goofy that could never happen mean for solution-wise? No solution. Yes? And you could do really quickly, if you say this was on a test and you're not quite sure if you made a mistake somewhere or whatever, how could you verify that this was no solution? You could do it the other way and see if it still worked. Okay, what's another way you could check to see if there was no solution? Put it in slope-intercept form and see whether it is. What is no solution? They're parallel, so they would have the same slope. Same slope, right? Same slope, but not same y-intercept. Okay. No, if you do you want me to do elimination just for fun? Okay, so I'm going to multiply the top by 2. So I get 2x minus 4y equals 6, and then I get negative 2x plus 4y equals 1. Cancel, cancel, I get 0 equals 7. So again, I got something goofy that doesn't make sense, which indicates no solution. Okay, let's try the next one. Try the next one. Oh. I am going to multiply the top by 3. So 15x plus 3y equals 48. 2x minus 3y equals 3. 17x equals 51, so x equals 3. Then I'm going to sub it into whatever. So 5 times 3 plus y equals 16, so y equals 1. So my point of intersection is 3, 1. And don't forget, you can still verify to make sure you get 100%. I caution you on the test to verify every single time you do it. I would verify at the end when you finish the test. Then when you have time, you verify. Because you want to be able to finish the test, right? Okay, I'll give you a second to do this, but maybe I'll help you with trying to get this set up here. We don't like fractions, so how could I get rid of fractions to start with? Why 12? Yeah, 4. I would times by 4 first. So when I times this by 4, what do I get? These cancels. I get 3x. These cancel, and I'm left with a 2. So I get plus 2y equals 16. Okay, so again, if I times 3 over 4 by 4, do you see that cancels? And I'm left with a 3. That's how I'm getting the 3x. Then if I take 1 over 2 and I times it by 4, do you see I can cross cancel? 4 over 2 reduces to 2 over 1, so that's how I'm getting the 2y. And then, of course, 4 times 4 is 16. So now what would I have to do to get these to eliminate? Yeah, so I'm going to times this now by a negative 3, which I can see now why Gavin's saying 12 to begin with, but good on you for that. Anyway, so I'm going to times this by negative 3, so negative 9x minus 6y equals negative 48. So everything cancels. So what does that indicate? Okay, so it's infinitely many solutions, but you have to state it's supposed to be on a certain line, right? It's not just any old thing. Like you can't just say, oh, 0, 2 works, because it doesn't, right? So although this indicates that it's infinitely many solutions, this is what I want. So if you get this and it doesn't say how many solutions, you're supposed to say any x comma y that is a solution in, and state one of the equations, like 3x plus 2y equals 16, or 9x plus 6y equals 48. Okay, and I will repeat why I'm saying this. Infinitely many solutions doesn't mean anything works. It means anything that you can put in here works. So for instance, if I choose to be x to be, let's say x to be 2, right? If x is 2, 9 times 2 is 18. Subtract that to the other side, I get 30. So 6y is 30, so y is 5. So when x is 2, y is 5 would work. What happens if, I don't know, x is 0? You see x is 0, what would I get y to be? 8. Do you see? It's anything that will you actually solve to work. But I can't just say, oh, well, 0, 0 works. It doesn't. Look, if I put 0 in there and 0 in there, does 0 equal 48? No. It's any solution that you could solve in this would work. That's on that line. Okay? And I think that's all.